Yeah, good evening, everyone. And thank you for giving me the opportunity to do this with you. I will just get into it now without wasting more time. I will start from the derivation, like the mathematical expression of all the subsections, and I will try as much as possible to speak explicitly in clear terms and without wasting more time. So, sorry. Okay. There being our demand in period I, our QI quantity our holding cost I, our xi plus 1, then our inventory quantity carried from I from period I towards I plus 1. That is carried from period I to I plus 1. Let's say carry the inventory quantity carried from period 1 to period 2, or the inventory quantity carried from period 2 to period 3. So the PCI, this is not exactly applicable in the whole calculation, but let's just put it there. Purchase cost of items in period I. So there, QI, this is a selling price, and this is a setup cost. So schematically we have our inventory. This is our starting inventory. Let's term it as XI. This is our starting inventory. You understand? Our starting inventory enter our first period of operation. Let's say our first period of production, the period I, the period 1. So by the time this inventory actually enters this period 1, two things actually take place. We make production of quantity I. Then this production made is to meet the demand of DI. So inventory that we actually start with is S subscript I. We actually make a production of QI to meet the demand of D subscript I. So after performing all these things, the inventory left after meeting this demand is I XI plus 1. And this inventory I plus 1 goes to period what? Period I plus 1. Let's say we actually started from period 1. We go to period 2. You know that I plus 1. Let's say I is 1. 1 plus 1 is 2. This one is I. This is 1. Something like that. So the inventory coming from our period 1 that is left after performing this production and meeting this demand is S subscript I plus 1. And after getting to this particular point, after getting to period XI plus 1, we made a production of QI plus 1 to meet the demand of what? DI plus 1. Then this continues like that. Let's say this period, let's say our I is 1. for our period 1. This is our starting inventory for our period 1. We actually produce quantity Q of 1. Then we met the demand of D of subscript 1. Then after performing this whole thing, the inventory that is left is dx subscript I plus 1. That is x of 2. S subscript 2. Inventory x of 2 now is the inventory that was left after performing the operation in period 1. And this goes into period 2. This goes into period 2. So mathematically, we can say that this inventory that enters period 1 plus the quantity that was produced should be equal to the demand that we meet. Should be equal to the demand that we meet plus the inventory that actually that was left in this period 1. This is the inventory that we actually took in. I took in, let's say, 10 units of 10 units of bag of sugar. 10 units of bag of sugar. You understand? This is my inventory. 10 units of bag of sugar. This is my inventory. And I use 5 units in producing. 5 units in producing. 5 units in producing a particular product to meet 5 units of demand. So after that particular 5 units, what is left in my inventory is just 5, which is this xi plus 1. So to represent this mathematically, we actually know that if I'm to add the inventory that actually I started with plus the one I produced should be equal to the inventory that I actually made plus the one that is left. So xi plus qi should be equal to di plus xi plus 1. So I can say here that the inventory I started with now, my starting inventory is equal to di plus xi plus 1 minus my qi. Take the equation 1. Then the inventory, let me just starting inventory. Equation 1, my starting inventory. So the inventory I ended with in period 1 now, that is xi plus 1, right? So if I'm to make si subscript x subscript I plus 1 the subject of the formula here, the subject of the formula here, it will now be xi plus 1 abi now is equal to what? Xi plus qi minus what? Di. Make this one 2. This is what? My closing inventory for period I. Right? So in this particular model now, we have some constraints. Look at this. Look at this schematic diagram. It's actually believe and of course a constraint that actually says that the inventory coming out here, the closing inventory of period I, cannot be greater than the succeeding demand in order for us to minimize costs. Because the end goal of modeling, of performing this model, is for us to meet the demand. Like, it's for us to actually know the quantity of product that we have to produce in order for us to meet the demand at the minimum cost. So in such case, we need to actually find a way to produce, to actually carry an inventory that will reduce our holding costs. You understand? So if our aim is actually to reduce our cost, then the inventory that's actually going to the succeeding period cannot be greater than the sum of the demands of the succeeding period. That is, let me say this is my xi plus 1 is equal to let me put it as question mark. You understand? Let me say let's say this is our period 1, right? This is our period 2, then we have period 3. Let's say our demand for period 2 is 4. Our demand for period 3 is what? Is 2. Our demand for what? Period 4 is 2. You understand? So you know that this period 2 and this is the closing inventory for period 1, and based on what this model is saying is the inventory that is coming out from period 1 cannot be greater than the succeeding sum of the demand of the next periods, so that the sum of the succeeding demand should be greater than or equal to the inventory, this inventory here. So if I have to add this one now, D2 plus D3 plus D4, that's 8. So xi plus 1 should be less than or equal to 8. That's what this one is. And in that regard, it is actually represented as 0 less than or equal to xi plus 1 less than or equal to summation j is equal to I plus 1 to n d subscript j. So for our x of 1 now, let's say for our period 1, this one will be x2. So this one will be x2, right? So if you have to put 1 here, 1 plus 1 here, this one will be 2. So d2 plus d3 plus d4 plus d5 should be greater or equal to this inventory here. This is our first constraint. You understand? Then we have another constraint that we need to observe, which is q of I this is our 2, where our q where our q of I is equal to what? Maximum our d of I plus minimum xi plus 1, right, minus maximum x of I, right, then comma 0, and maximum d of I plus max xi plus 1, right, minus minimum x of what? I to 0. So there's the constraint. So for the total cost, let me just put it like this. For the total cost now, the cost of inventory is equal to f. Whenever you see this f now, is actually saying cost. Let's say f of x1, the cost of inventory of x1, f of x2, the cost of inventory of x2. But if you actually need to see x2, that is the quantity of inventory itself. X2 is quantity of inventory of period 2. If you see x1, quantity of inventory of period 1. But if you see f of x1, that's the cost of inventory of period 1. If you see f of x2, cost of inventory of period 2. So for this now, xi plus 1, right, is equal to ei plus, we need to note this formula very well, q of I. This is not to be our setup cost, and this is said to be our purchase cost, just as we established earlier plus what? Our h of I into bracket x I plus 1. This is our holding cost. Holding or carrying cost. Then plus our f I minus 1. Then our x I plus 1 plus d of I minus qi. We need to know this formula. It's very important to know this formula. This is actually what you are trying to minimize. We are trying to minimize the cost. We are trying to minimize costs by considering these two constraints. By considering these two constraints, this constraint 1 and constraint 2, we are minimizing this cost by considering these two constraints. So mathematically now, I can write that my model now. So I can write that my model tries to minimize f of what? F of I, what I just put here, x I plus 1, subject to what? To this constraint here, these two constraints here. And those. So there is something we need to know about this setup cost. Sorry, can you see my stuff? There's something we need to know about this setup cost. We should know that setup cost actually, takes its validity when there is a quantity of product involved. When there's a quantity of product involved, that is, if there's no product being produced or purchased, this our what's it called now? This sigma now will be 0 because there won't be any setup cost. It is when something is produced that this one will takes its validity. But when there's nothing being produced or purchased, this one will be 0. And if this one is 0, automatically our setup cost is 0. Do you understand? So let me just write it now. Let me put it here then. Is 1 qi greater than 0. That is if there's something if something is purchased or produced, that is when it will be 1. And if this is 1, this is our setup cost. We assume its validity. But if it is 0, then our q of I will be equal to 0. Do you understand? Do you understand why this one is 0 now? Like why this one will be 0 and why it won't be 0? This condition, when it is met, then we need to factor in accordingly. So for dynamic programming, we have two methods. Approach 1 is forward pass approach. This approach is used when demand is small. When demand is small, while the other one backward. This is used when there is high demand. And we will see the applicability of this as this progresses. So let's consider the example that was given in the material period. So we are considering 3 periods here. we have the demand D of I, 2, 3, 2 and 4. Setup cost. Well done, sir. That's our E of I. Don't forget. We have the holding cost. We have our I, 3 and 2. And we are giving our selling cost, that's our selling price, to be BIQI, of course, like the way we actually said earlier. Is 10Q, 10QI, if what? If Q of I 3. This holds its validity. We are going to use this. This holds its validity when it is 0, when it is 1, when it is 2, and when it is 3. And for this is 30 plus 20 Q I minus 3. And this holds its validity if what Q, that is the quantity we have to produce, is greater than 3. That is, if it is 4, if it is 5, if it is 6, like that. I'm very sure you'll be wondering that why are we going to use this when 0 is already involved? When 0 is, but as we progress, you actually see what this means.